Hello, I am Baltej, and you can see me. I was just viewing D-Lang. D is a general purpose programming language, and your code here. Ha. And if you try to run it, the average line length is 19.5. I've realized that every language that okay, every language that a person can do, that person can learn, is just a way to provide the compiler, to provide the CPU some sets of binary instructions which are pretty much same in every language. Even if you use an interpreter, even if you use a compiled language, at the core level it's just the same binary instructions given to the CPU. So it's no good learning 10 different languages. It's always better to learn one single language, and you must be good at it, correct. And good and good. And I was at reference and borrowing. I saw that we can't have two mutable reference to the same data member, to some same value, to some same data. And should I show you something? FF play. Okay, desktop. I was working with referencing and borrowing. Then I got to know that you can't have multiple references to the same, what we call, same data. So which means I can't call this.
अच्छा। और आप क्लास आ रहे हो? हाँ अभी जाना है भाई पेपर से। कैसे हुआ?
अरे सुबह सुबह कोडिंग।
ICCS बोल रहा है।
अरे चलो ठीक है, मैं क्लास में
अच्छा ठीक है।
आज अपने लंचेस किया यार। ओ गौरव, I can call this function twice. For sure, I should be able to. Ah, and the point is that I can't take a reference of let ref1 equals to reference C, and let ref2 equals to C. Now let's try to do it. Huh? It works. It worked. Here ref1 just ended. If I use ref1 here and tell them, for example, ref1, then that's little wrong. The hell? The hell? Okay, we can't have mutable references. looks. And this error says that the code is invalid because we cannot borrow s as mutable more than once at a time. The first mutable borrow is r1 and must last until its use in println. But between the creation of that mutable reference and its usage, we try to create another mutable reference in r2 that borrows the same data as r1. The restriction preventing multiple mutable references to the same data. Okay, this is for the race condition. Data races can cause undefined behavior and cause difficult to diagnose and fix when you are trying to track them down at runtime. Rust prevents this problem by refusing to compile code with data races. As always, we can use curly braces to create new scopes along the multiple mutable references, just not simultaneous ones. Curly brackets to create new scopes. Multiple mutable references, just not simultaneous ones. Let r1 equals to mute s. Let r1 goes out of scope here, so we can make a new reference with no problem. And it works. Rust enforces a similar rule for combining mutable and immutable references that goes result in an error. Let mut s is equals to string from hello. Let r1 is equals to reference to s. Let r2 is equals to reference to s, and let r3 is mutable reference to s. Shouldn't lie error, yeah. This is correct. There is only one single mutable reference. We also cannot have a we cannot have a mutable reference while we have an immutable one to the same value. This should be an error. This is bad for Rust. Equals to reference to. This should give me an error. No, it works. But after this, can't have that ref4 equals to reference mut c, and I need to use c also. Print ref3 ref4. Here's an error. Can't you mutable and users of immutable reference don't expect the value to suddenly change out of users of an immutable reference don't expect the value to suddenly change out from under them. However, multiple immutable references are allowed because no one is just reading the data as the ability to affect and continues through the last time that references is used. For instance, and the scopes of immutable reference R1 and R2 are after the println where they are last used, which is before mutable reference R3 is created. These could not hold up, so the code was allowed. Even though boring errors might be frustrating at times, remember that the Rust compiler pointing out a potential bug early at compile time rather than the runtime and showing you exactly where the problem is. Dangling references. What is this word?
Erroneously.
In languages with pointers, I didn't saw the meaning of it. In languages with pointers, it's easy to erroneously create a dangling pointer, a pointer that references to a location. That references a location in memory that may have been given to someone else, but freeing some memory while preserving a pointer to that memory. In Rust, by contrast, the compiler guarantees that references will never be dangling references. If you have a reference to some data, the compiler will ensure if you have reference to some data, the compiler will ensure that the data will not go out of scope before the reference to the data does. Let's try to create a dangling reference to see how Rust prevents them with the compile time error. Reference to nothing, dangle. I returned a pointer. How is expected name lifetime parameter static? This shouldn't be wrong. The ownership of S goes from here and is returned to the reference to nothing to the main function. And I am returning a reference. This is the classic example of dangling or null pointer. Not null pointer, dangling pointer in Rust, but it seems to be okay to me. What am I? Not be wrong. I'm missing when ownership is dropped and reference is allowed to point to. When ownership is dropped and what a reference is allowed to point to. The ownership initially was here. The ownership was transferred to the main function. The ownership shouldn't be dropped. The ownership of should be dropped here. Okay. And your mental model is certainly C-like, not Rust-like. That exactly Rust is preventing that. Let's go slow and precise, no flop. Restated. Okay, you're thinking ownership of S goes from dangle to main and just returning the reference. And I'm just returning. Assumption is wrong. Ownership does not move via references. Oh. Okay. Ownership is not the reference. Reference is not. Reference was exactly created in Rust because the ownership was always transferred to the function and we have to return the ownership back. Okay. It's not the CPP reference, it's not the C reference, it's Rust. It's Rust. Perfect. Function. Let's create a dangling pointer and I'm going to return a reference to string. It takes nothing and it returns a reference to string. Let's string from this. I return the reference to string. Okay, let's see. Could not compile. Unused ref4. So here we got a lifetime parameter error, which was like, which I thought lifetime parameter error. Time parameter error. Easy. And gc3 done and works. And I have a message refer to the feature we haven't covered as lifetimes. Oh no. This error refers to a lifetime. We'll discuss lifetime in detail separate and but if you disregard the part about lifetime, the message does not contain the key to why the code is a problem. This function's return type contains the borrowed value, but there is no value for it to be borrowed from. Dangle returns a reference to string. S is new string. We return a reference to string S. When the code of Tangle is finished, S will be deallocated, but we try to return a reference to it, which means the reference would not be pointing to invalid string. The solution has to return the string directly. Makes sense. No dangle. Let's write the function. No dangle. No dangle. And returns a string. Perfect. And then it returns a mutable string. That's not how it works. Will it compile? Is this okay? Okay. It's not returning a reference, so it's okay, I guess. Let's get trusty. So we were on node angle. String is equals to string new, let's say, and this should work. This should work. Return str. So 11J, yep, it works. This works. This is node angle, that is angle. Node angle. This works without any problem. I know ship moved out, nothing is deallocated. The rules of references. Let's recap what we have discussed about references. At any given time, you can have either one mutable references or any number of immutable references. Reference must always be valid. In pattern matching, defining enums, I have seen this a lot. Let's see what this chapter has to offer. And this is a small chapter. Let's read it continuously. Slice, the slice type. Slice let you reference a contiguous sequence of elements in a collection. What is a collection? Collection. The standard library includes a number of variety useful data sets called collections. Most of data type represent one specific value, but collections can contain multiple values. Unlike the built-in array and tuple types, the data that these collections point to is stored on the heap. But collections can contain multiple values. Unlike the built-in array and tuple types, the data that these collection points to is stored on the heap, which means the amount of data does not need to be known at the compile time and grow and shrink at the program as the program runs. Each kind of collection can has different capabilities and costs, and choosing an appropriate one for the current situation is a skill you develop over time. This chapter we'll discuss. This is chapter 8. Chapter 8. 22 chapters. Crazy. Wow. And the slice type. Slice lets you reference a contiguous sequence of elements in a collection. A slice is a kind of reference so that it does not have ownership. It is a small programming problem. Write a function that takes a string of words separated by spaces and return the first word it finds in that string. Okay, what is a small program? Write a function that takes a string of words separated by spaces and returns the first word it finds in that string. Let's write the function. A function which takes first word, which returns the first word out of a string, and it should return a string. Otherwise, if I do this reference to string, that will be a dangling pointer, and I should do this, and now give me a string. This should be a reference. Turn the first word out of the string. How should I do that? Okay, I should actually give back a reference for sure. Yeah. Let's okay, a loop. Let I equals to 0, I is less than s dot len, and len is a function. What? Len is a function, and I plus plus. This should work. Print something. Just hey, cargo run is not compiled. F2 intended, loop expected. Okay, loop, not ChatGPT. W3 schools.com and tutorials. Rust. Huh? There's no Rust. There is no Rust. Wow. For I equals to 0, I less than. Okay, this should work. For I in 1 to 6. For I okay, this and expected string found nothing. Returned anything. Okay, I should return a string. I should just return S, a reference to S. That should fix it. Yeah. And reference to S. It prints hey. No, because I never called this function. Yank till. Okay. this works. Okay, no problem. Slice. I work. God damn. Didn't do that. Okay, yep, I need to send a reference. Talks. What I can do is I can define a variable. Let res let mut res equals to string new, and then just if what is I this works. This works in Lua. To get a character from a string in Rust. Look at first correct. Oh, wait. Oh, no, not this one, not this one. Chars. S.chars iterator. Perfect. Very good. S.chars. And I just need not char. Okay. If char equals to space break, otherwise just break. Actually don't need a reference. I don't need to send a reference. Need a reference here. I'm not returning it. Do I need to send a reference back? Yeah. Otherwise it's gonna be a dangling pointer. Yep.